This video will be all about 2.3 using squares to find lengths of line segments. You can throw that in on the end. Okay, so now we're going to take everything that we've done so far in this unit now to do something like this. This is very important in all of algebra to be able to find lengths of line segments. So let's say that you have 2 points on a coordinate grid, and you want to find the length of that line segment in between. Okay, well, now we know that we can't just add up or count because the distance from there to there is 1 centimeter, but we don't know what that horizontal distance is. That's 1 centimeter. That's 1 centimeter. So we know that this triangle is 2 centimeters by 1 centimeter, but up to this point, we have not had any methods to find the length of that side. Okay, so that is what our focus is going to be on in this video. So let's take a look at this. Okay, so you got your notes started, 2.3 using notes to find side lengths. Now on the graph paper that you're taking notes on, or if you're not on graph paper, get a piece of graph paper. What I want you to do is I want you to draw a line segment. Okay, any old line segment. You can do the one that I'm about to do or any one that you want to. So what I'm going to do is I'm going to draw a point. If I get the colors. All right, so I'm going to draw a point. Then what I'm going to do is I'm going to go up here and let's say, right here's another point. And I'm going to connect those dots. Okay, our goal in this video right now is to figure out what is the distance between those 2 points. What is the length of that line segment right here? That's what I'm going to try to find. And we're going to set up squares to do that. Okay, so step 1, we are going to create our square based off of that line segment. Okay, so step 1, square the line segment. Now, this can be done by figuring out, number 1, what the slope is of this line. Okay, now from this point to this point, I go up 1, 2, and over 1, 2, 3, 4, 5, 6. So my slope is 2 over 6, and we're going to keep it as 2 over 6. Okay, because we're going to find another point, and that means that is going to be perpendicular, and so I know that this slope over here is going to be not 2 over 6, but negative 6 over 2, because that is going to be an opposite reciprocal slope. All right, and I'll show you what I mean. So from this point here, we're going to go down 1, 2, 3, 4, 5, 6, and then over 1, 2, and we're going to put another point right there. Now when I connect these lines, those 2 line segments will be at a right angle, okay? Because they are opposite reciprocal slopes. Now to find another point that's up here somewhere, I know that my slope is going to be parallel to this one up here, the highlighted yellow one. So it's going to be 2, 6. So I go up 1, 2, over 1, 2, 3, 4, 5, 6. Okay, and so this has a slope of 2, 6. And then this one, I should go up 6 and left 2. So 1, 2, 3, 4, 5, 6. 1, 2. And I do. So I know that this line right here is also perpendicular to that one. So these 2 lines are perpendicular. These 2 lines are perpendicular. And they are all the same length. That side, that side, that side, and that side are all the same length. So that is how the step number 1 is you're going to square that line segment. And now step number 2 is to square the square. This is what we've been doing. We're going to draw a square around this square because as of right now, we cannot find those the lengths of those side lengths. And we need to find the length of this highlighted segment right there. So we're going to go ahead and square the square. On your paper, go ahead and do that. Okay, so when we do that, this is what it looks like. Okay, and number 3 is we're going to find the area of our red square. And remember, how to do that is we're going to take the area of our outer square and we're going to subtract out the area of the triangles, and that gives us the area, that gives us the area of our square. Okay, and that is of our square. So the area of this outer square minus the area of the triangles, that will give you the area of the square. So go ahead and do that and then come back. Okay, so let's see how we did. If we go ahead and find the area of our, in this case, our red square, right? The area of each one of these outside triangles is 6 because they're all 6 by 2. So 2 times 6 divided by 2. So 6 times 4, that's where we get 24. So the area of our big triangle, since it's 8 by 8, that is 64. Area of, the big square is 64. The area of those triangles is all 6. So there's 4 of them. So that's 24 total. And then the area of our red square there, that's our goal, is 64 minus 24, and then that's 40 square units. Now, the fourth and final, in order to figure out what this side length is right here, the fourth and final step is to square the area root, so square root the area of the first square. A-R-E. Okay, and then this is the side length of the first square. So what that looks like is if we know that the area of, I'll do this in red just to keep it consistent here. If we know the area of our square there is 40 units squared, then the S, which is the side length, is going to be equal to the square root of 40 units. Okay, so that's the area of the side length, and then that's the side length, and that's the distance right here. So the length of that line, that side length, is the square root of 40 units. So the distance from there to there. Now, if you needed to estimate this without don't use a calculator. If you needed to estimate this, that would be between, right, if we think about this, the square root of 40, that is between the square root of 36, which is 6 squared, and the square root of 49, which is 7 squared. So this is somewhere between those two. And it's closer probably to 36. So I would say that this is maybe 6.4, something like that. And so if we had to estimate this side length and as a decimal, this would be 6.4 units in length, somewhere around there. Okay, so make sure you have this in your notes. Highlight the important stuff, rewrite things in any way that you need to rewrite them. But our final goal is to get this value right here. What is the side length of that yellow highlighted side? And these 4 steps will get you there. Now, coming back to the notes, by doing what we did, we would have answered a lot of these. On number 1, we've already done this quite a bit, and I'm going to say let's go ahead and skip number 1, especially if you have this lab sheet. We took a lot of time on this lab sheet getting this done, and these are pretty much all the squares up to a 4 by 4. Now you can create a 5 by 5, but it will be out of the 5 by 5 grid. And the one that we just created is a lot bigger than these because our biggest one here was a 16 square units area, whereas the one that we did together was about, what was it, 64 square units. So it was a 6.4 by 6.4 square here. Okay, so on that first one, I'm going to go ahead and say that we're good as long as you have this in your notes. It looks good, things are highlighted, and you understand the steps. Also, on number 2, as long as you have this lab sheet, pull this back up, and you clearly have both the areas and the side lengths listed, both in terms of square roots. So what I mean by terms of square roots is this right here. This right here has a side length of the square root of 5 because the area is 5. Okay, so the square root of the area, square root of 5. And then we found that approximation to be 2.236 centimeters. As long as you have this and this for each one, you're good. This was our original approximation on that first day that we did things. Okay, so if you have that for number 2, I think you're good. Also on number 3, we've already done number 3 because we estimated all of those square roots, because it says estimate each non-whole number length to 1 decimal place. I'm going to show you what that looks like, but we've already done that. But you do need to be able to do this as well. That would be like this right here. We had all of these square roots as side lengths. Okay, we went all the way up to, I think, the square root of 13, and you needed to estimate what each one of those decimals were. We're not plugging them in the calculator. Very careful when you're doing this. Do not plug them in the calculator, because on the quiz or test, you will not be able to use a calculator to estimate some of these. And these are where you think to yourself, okay, for example, square root of 20, right? That's between the two perfect squares would be the square root of 16 and the square root of 25. And it's almost exactly between 16 and 25. Square root of 16 is 4. Square root of 25 is 5. So this is going to be around 4.5. Okay, so that's how you would estimate. So estimating square roots is one of our learning targets. So make sure you can do that. And then number 4, describe a situation where measuring to 1 decimal place is not accurate enough, where you'll need to go multiple decimal places out, where accuracy is important. So think about that. When would accuracy be this important? And then write down what you think, and then pause the video and come back. Okay, so probably the one that I thought of as the most important, having a spouse that's in medicine. Right, that's where those decimals are going to be hugely important, because if you're giving somebody an extremely powerful drug, whether it's to put them asleep or for pain, right, you want to be careful, because if you're giving the drug to an adult that weighs 350 pounds versus a baby that weighs 8 or 9 pounds, hugely different amounts of medicine between those two, or a child even that weighs 25 pounds, their metabolism will work with that drug a lot different than what that older man, 300 pound plus man, will do. So medicine is the one that I can think of. Engineering too is when you're building structures. Accuracy is hugely important. So now for this one, for B part 1, you're finding the line segment length of figure 1. So that would be right here. I want you to go ahead and do this. You have a lab sheet that goes with this. And a lab sheet looks something like this. So now you're just doing figure 1. And what you're doing is you're doing those steps that we talked about, those 4 steps to find that line segment. So go ahead and do that. Come back to the video and see how you did. So follow those 4 steps, whereas the first step is to square this line segment. Okay, here we squared the line segments. Okay, I know that the slope of the highlighted yellow line is 2 over 2 because I went up 2 and over 2 to go from this point to this point. And so the perpendicular line should have an opposite reciprocal, so it's going to be negative 2 over 2. So I would go down 2 from this point and over 2 to get to that point. Step 2 was to square the square. And when you square the square, it looks something like this. Then step 3 is to find the area of that first, in this case it's a red square. So let's see how you did. You find the area of the big square. Give me 1 second. You find the area of the big square, that's this one. And each side is 1, 2, 3, 4. So the area is 4 squared. Then your big square has an area of 16 square units. The area of the triangles, each one is 2. So the area of all of them is 2 times 4, which is 8 square units. And then the area of that red square, that first square, you subtract 16 and 8, and that gives you 8 square units. So that was part 2, is figuring out what is the area of this square. And we found the area to be 8 units squared. Then the last step is to figure out what that side length is. So one of the side lengths, since this is a square, all of those side lengths are the same. So if we found one, we found them all. And the side length is easy to find because it's just the square of the area. So in this case, our side length is the square root, it's the square root of the area. So it's just the square root of 8. So the side length is just square root of 8. So this side length is the square root of 8 units. Because if I wanted to find the area of that square, I would just take square root of 8 times the square root of 8. That's length times width, which is just 8. Now, since you have all of that, go ahead and on figure 2, find the side length of this line right here. Pause the video, try that. Now I'll give you a hint. You're going to have to go outside a little bit of these dots when you draw that first square off of that line. Pause the video and try this on your own. So when we go ahead and square that square, first of all, find the slope of that yellow highlighted line, and that is 2 over 6. So I know that the perpendicular line is going to be the opposite reciprocal, which would be negative 6 over 2. And when I draw that line from that dot to that dot with a slope of negative 6 over 2, it will be perpendicular, meaning they form right angles. And then I just go from there. You notice I'm going to have to create a dot over here because when I go over 6, I'm here. Then up 2 will give me right there. Now step 2 would be to square the square. So now that I've squared the square, I'm going to go ahead and find the area of my first square by subtracting out the area of all of those triangles from the large purple square. And when we do that, the area of our large square is 64 units squared. Area of those triangles, they're all 6 by 2, so the area is going to be 6 times 2 divided by 2, which is all 6. And so there's 4 of them, so 6 times 4 equals 24 square units. Those are the areas of all of those triangles. And then we subtract those to find the area of our square. And now the final step is to figure out what is the side length right there. And that side length is going to be the square root of 40. Whoops, this just happened to be the one we did at the beginning. Okay, so it's going to be the square root of 40. That's our side length. Now if we come back here, on number 1, Ella says that the length of the line segment, so we answered that question already. We know that this length right here, since we found it, was the square root of 8. The length of that, the length of this was the square root of 40. Okay, and we'll just say units. Put that in there. So on the first one, Oscar says it's 2 square root of 2, not square root of 8. Do you think that they're both the same thing? In your calculators, go ahead and find what square root of 8 is, and then take 2 times whatever the square root of 2 is. Go ahead and find that in your calculator. Okay, and when you do that, you should have found that you get the same thing. They're both equal to 2.828. Weird, right? Let's think about why that happens. Let's zoom in a little bit and look. Listen, this line segment is actually made up of two smaller segments. So for example, here's one smaller segment, and I'm going to pull it up here just to make it separate. So that is one of the line segments of that complete line segments. Okay? Okay, go ahead and try number 2 on your own, expressing the exact length of this line segment in figure 2 in 2 ways, and then come back and see how you did. Okay, so when we square that line segment, it looks like this. When we find the area of this square in here, this area, we got to be the square root of, the area is just 10. There it is. When you found the area of that, which we've done multiple times already, the area is 10 because you find the area of the large square around that square and then subtract each one of those triangles away, the area of those triangles, and you end up getting 10. So that means that this side length is the square root of 10. Okay, so that means that this length right here also is the square root of 10. And this length right here is the square root of 10. And so the length of that total line is square root of 10 plus the square root of 10, which is 2 square root of 10. In your calculator, see if the 2 square root of 10 and the square root of 40 are the same thing. Go ahead and punch those in your calculator and see what you get. Okay, so for the square root of just 10 times 2, there I got 6.325. And then when I found the square root of just 40, I got 6.325. So that's how we know they're the exact same thing. Different ways to find them. Number 3, can you find a line segment whose length cannot be expressed in 2 ways? Absolutely. There are ones that cannot be represented in 2 ways, and I'll give you a hint. The one thing that these both have in common, right? The square root of 8, let me get a different color. What the square root of 8 and 40 have in common is they're both divisible by a perfect factor. Okay, so square root of 8 is divisible by 4, and this is divisible by 4. Because 4, the square root of 4 is 2. The square root of 4 is 2. Okay, so if these square roots are divisible by perfect squares, then you can write them differently. Go ahead and explain that in your notes. If the square roots are divisible by another perfect square, like 4 is a perfect square, 16 is a perfect square, 25 is a perfect square, then you can rewrite it. Otherwise, you cannot. Number 4, which of the following lengths can be expressed in 2 ways? We'll look at these, 5, 10, 18. Are any of those divisible by perfect squares? Think about it. Only one of them is divisible by a perfect square, and that is this one. Okay, so I'll show you algebraically. You can do it on a grid if you want to, but I'm going to show you algebraically. Well, the square root of 18, I know 9 will go into 18, so this is the square root of 9 times 2. That's 18, okay? I can divide this up into the square root of 9 times the square root of 2. That's the same thing as that. All right, square root of 9 times square root of 2 will give me square root of 18. But now I can look, okay, well, I know the 9 is a perfect square, and so then that will be 3 square root of 2. And so now I rewrote the square root of 18 as 3 square root of 2. And if you check your calculator, they are the exact same thing. Now, on your quiz and test, you will not be expected to do this, right? If you leave your answer as the square root of 18, I think that would be just fine at this point, but this is just looking at, hey, I can rewrite some of these, and this up here tells me why am I able to rewrite some of them and not all of them, because we're able to divide them into two equal but separate line segments. But with these down here, if you write them out and look at them, you cannot divide those line segments up into half on those grids. Only if they're divisible by a perfect square. Okay, so that is it for 2.3, using squares to find lengths.